Hello and welcome to Lesson 4 of Unit 11. So far in this unit, we've been talking about data in one variable, so just collecting a single number from a bunch of people to try to get a measure of, how many cars people in our school own, how many pairs of shoes they own, how many times per week they exercise. But this week, we're going to start talking about bivariate data. This is the type of data that people use when they're trying to establish a correlation between two different things. It might be something like, how many times a week do you exercise and what's your blood pressure? If we measure both of those things and it seems like the more people exercise, the better their blood pressure is, maybe we can start to establish a correlation between these two things. Here is an important note. Correlation does not equal causation. When we measure these two variables, when we're measuring, back to our example, exercise and blood pressure, showing that there's a correlation between the two, showing that the more you exercise, the better your blood pressure is not actually proving that one thing causes another. All it shows is that in a person who exercises more, they are more likely to have better blood pressure. And there are a number of things that could contribute to this. Maybe someone who exercises more also just has a more relaxed lifestyle, and that's what allows them to get all this exercise in. Maybe they're not working a side job, so they get more opportunities per week to exercise, and it also means they have lower blood pressure because they're less stressed. Another example of correlation not equaling causation might be something like the more someone drives to school as opposed to walking, the more likely they are to suffer lower back pain. And you might think, oh my goodness, driving is bad for your lower back, but it could also just be that the people who drive to school the most at St. Peter's are the teachers, and we're just a bit older than you, so we get lower back pain. So there's another example of when correlation, two things happening in sync with each other, is not the same thing as causation. It's not one thing causing the other. So let me put that up on the board for you. So let's think of an example, and as we work through it and create a two-way frequency table for this, we're going to see how we can use this table to either show correlation or no correlation, and how we can use this table also to try to avoid false representation of our data. The question that we're going to start with is, do you prefer sports cars to SUVs? And also, are you a man or a woman? So you can see the overall question here is basically trying to figure out whether women or men prefer sports cars more or SUVs more. There's two variables going on here, man or woman, and also sports car or SUV. The first thing you're going to do when you're building a two-way frequency table is you are going to create columns and rows. Each of these will represent one of the variables that you've asked about. In our table, we're going to create two rows, one for male and one for female, and two columns, one for SUVs and one for sports cars. This is going to allow us to place numbers in each of these cells and have them represent something that applies to both whether it was a man or a woman who answered, and then also whether they chose SUV or sports car. So here we're going to put 21 men said they would prefer an SUV, 39 said they'd prefer a sports car, 135 women said they'd prefer an SUV, and 45 said they'd prefer a sports car. Now you can see right off the bat, right, that there are a lot more people in this cell than in this cell, and more people in this cell than in that cell. A preliminary look at the data is going to show you that there are just more women who answered this question. And this is something that happens a lot when collecting data. It's very difficult to actually make sure that you get the equal amount of men and women answering a question when you ask one. Surveys will be sent out to lots of people, and the people that choose to respond may or may not be the people you're looking for. We have ways to actually take all of that into account when we are processing our data. Before we really get down into doing the kind of math that's going to make this picture really clear, I'm just going to add a few more rows and columns to this table that represent total amounts. So here at the bottom, I'm going to make another row where I add up the number of people who chose sports car and the number of people who chose SUV. So here we're going to have 156, and here we're going to have 84. So if we add these two numbers, we get that number. If we add these two numbers, we get that number. And these are the totals. I'm now going to do the same thing for my rows. So that was for my columns, and I can do the same thing for my rows. Over here, I can add that 60 people in total were men, and then 180 people in total were women. I can make this third column of totals. So these numbers represent how many people chose SUV and sports car, regardless of their gender. And then these two cells represent how many men answered and how many women answered, regardless of what car they chose. You can see the totals mean different things despite the fact that they're both totals. The very last thing that we're going to add is a total amount in this last cell here. That's the total of just everyone who answered. And that total number is 240. The last thing I'm going to do in this lesson is just label some things. So I want to get used to using the vocabulary associated with a table like this. These 4 cells are called joint frequencies. So each of them is showing the frequency of 2 things happening at once. A man who likes an SUV, a woman who likes a sports car. Those are joint frequencies. Then, in these 2 rows, or rather this column and this row, we have what are called marginal frequencies. And that's just the probability of one of the variables happening, right? So of the people, all of the people, 156 of them like SUVs. I'm only talking about one variable here. Of the people, of all the people, regardless of what car they like, 180 of them are female. So I'm just going to label that last of all, and we'll stop there for this lesson. Unfortunately, I think that made my table a little messy, but hopefully you were able to understand what I was saying, and you can see which ones I've labeled. So far we've found a way to organize information really clearly into a table when we've asked a question that really looks for 2 different variables. Based off of our preliminary information, you might start making some assumptions about which ones are correlated. And you may actually be right about your assumptions, but in our next lesson, we're really going to talk about how to solidify our inclinations, like what we actually think this data is saying.